Here we are given an equation of a curve, and it has a horizontal tangent line at the point 5, 1 and at one other point. And we want to find the coordinates of the second point where the curve has a horizontal tangent line. For step 1, we need to find the slope of the tangent line. And to do that, we are going to find the derivative. I'm going to use implicit differentiation to find that. For the first term, we'll have 16 times 2 is 32x minus 160 plus 18y times dy dx plus 54 times dy dx is equal to 0. I'll keep the terms on the left side that have dy dx and factor that out. And at the same time, I'm going to subtract the 32x and add the 160 to both sides. And so we have the quantity 18y plus 54 dy dx is equal to negative 32x plus 160. And now we have a derivative of y with respect to x when we divide both sides by 18y plus 54. So that was step 1, to find the derivative. Now step 2, since the horizontal line has a slope of 0, we will set that derivative equal to 0 and solve for x. So step 2, we set this derivative equal to 0 and then solve for x. Well, for this quantity to be 0, the numerator is 0. I'll subtract the 160 on both sides and divide both sides by negative 32. And so we get x equals 5. And so this looks good here so far. You can see that we already know it has a horizontal tangent line at the point 5, 1. So now, step 3, we're going to find the other y by plugging this 5 into the equation of the curve. So going back up to the original equation here, I'm going to plug in 5 for x and then solve for y. So we have 16 times 5 squared minus 160 times 5 plus 9y squared plus 54y is equal to negative 337. And then if we simplify this, set equal to 0, we will have 9y squared plus 54y minus 63 is equal to 0. Each of these terms is divisible by 9, so let's divide both sides by 9. We have y squared plus 6y minus 7 is 0. We can factor this into y plus 7 and y minus 1. And so one of these factors has to be 0. If we set them each equal to 0, solve for y, we have y is equal to negative 7, or y is equal to 1. Going back up to the original problem, we see that we were given 5, 1 as a point, and so here we have 5, 1, and so the second point where the curve has a horizontal tangent line is at 5, negative 7.